In a rapidly evolving world of electric vehicles, EVs, continuous innovation is essential to enhance their performance. Rivian, a leading player in the EV revolution, has recently made a significant decision to adopt LFP, lithium iron phosphate, batteries for its entire lineup. The company asserts that this switch will substantially reduce the cost of their EVs, making them more competitive in the market. But what sets Rivian's new battery technology apart, and how does it differ from existing EV batteries? Additionally, how will this new technology impact the price of Rivian's vehicles? Furthermore, what are the potential environmental implications of this battery technology, and can it contribute to the overall sustainability of EVs? Lastly, how will other EV manufacturers respond to Rivian's adoption of LFP batteries? Rivian faces substantial pressure to overcome market challenges, increase production, and achieve profitability simultaneously. The company faced a challenging year in 2022, with disappointing production statistics and financial performance, leading to concerns about the sustainability of its cash reserves. Without improvement, Rivian's financial situation would only allow for another 2 years of operation after suffering over $7 billion in losses last year. However, the first quarter of 2023 brought positive results for Rivian, surpassing sales projections. Now, the company aims to enhance the performance of its regular range R1T, R1S vehicles and EDV, electric delivery vans, by incorporating new battery packs powered by LFP cells. The first quarter figures exceeded expectations on Wall Street, boosting confidence in Rivian's growth. LFP cells offer advantages such as affordability, stability, and availability compared to their NMC, nickel-manganese-cobalt, counterparts, albeit with lower energy density. Rivian plans to compensate for the reduced energy density by increasing the number of cells per pack using a cell-to-pack approach. The CEO of Rivian announced on Twitter that these new packs will be installed in vehicles later this year. To accommodate the lower energy density of LFP cells, Rivian intends to modify the interior design of the battery packs. Traditional EVs typically employ a module-based construction method, where cells are grouped together in packs and interconnected within the final enclosure attached to the vehicle's floor. Instead of using modules to maximize cell quantity within the available space, Rivian aims to adopt the cell-to-pack approach for its LFP packs. Tesla's vehicles equipped with the new 4680 cells also utilize this technique. Rivian temporarily halted EDV production during the quarter to prepare for the integration of LFP battery packs and the upgraded Enduro Doctor units. Unlike most EV startups that outsource drive units, Rivian initially took this approach to expedite manufacturing. However, the company later developed its in-house Enduro Doctor units. The EDV vans will be the first to receive the new motors, followed by the R1T and R1S models. Due to the redesign and the increased number of cells per pack, Rivian anticipates that the LFP cells' lower energy density will be adequately compensated. It remains uncertain whether Rivian plans to replace the current 21,700 cells, 21 mm in diameter and 70 mm in length, with newer versions of the same chemistry or different cell form factors. The decision to adopt LFP batteries is primarily driven by the challenging supply chain environment faced by Rivian and its suppliers, which is attributed to the COVID-19 pandemic and Russia's invasion of Ukraine. Rivian's CEO mentioned on an earnings call that they are procuring the initial LFP cells through a partner, while also developing in-house battery chemistries and production capabilities. In its shareholder letter, Rivian stated that the EDV 700 and other commercial vehicles designed for Amazon would have similar daily range capabilities with LFP chemistry, offering significant cost savings. Rivian estimates that the LFP-based conventional battery pack will provide a range of over 260 miles in their consumer electric cars. Although originally planned for 2022, the deployment of LFP battery packs in EDVs is now expected in 2023. Rivian's CEO anticipates that LFP batteries for passenger cars will be available on the market by the end of the year, along with the improved Enduro Doctor units. The LFP cells will likely be developed in partnership with a Chinese company, while Rivian also explores its own battery research, including new chemistries. LFP-based Li-ion batteries are gaining popularity in EVs, with other manufacturers also adopting them for lower-priced variants. For instance, Ford is constructing a facility to produce LFP cells for its basic electric car models. Similarly, Audi plans to utilize LFP chemistry in several European trims, and General Motors is considering a similar transition. These companies are following in the footsteps of Chinese EV and D battery manufacturers. In October 2021, Tesla announced its intention to switch to LFP battery cells for regular battery packs. Approximately 95% of LFP cathode production occurs in China due to the country's extensive promotion of this technology. Rivian's adoption of LFP batteries showcases their commitment to innovation and cost reduction. The environmental implications are noteworthy as well, given that LFP cells do not require materials like nickel and cobalt, which can be expensive and challenging to acquire. Although LFP cells have lower energy density, they offer advantages in stability and lifespan, as they can be fully charged and discharged without compromising cell integrity. It will be intriguing to observe how other EV manufacturers respond to Rivian's embrace of LFP battery technology. As the EV industry continues to evolve, the adoption of LFP cells can contribute to the broader sustainability and accessibility of electric vehicles. The shift to LFP batteries by Rivian is indeed significant, as it offers potential benefits in terms of profitability and lower prices for consumers. By eliminating the need for cobalt, LFP batteries reduce the reliance on countries associated with human rights violations and child labor issues, such as the Democratic Republic of the Congo, where cobalt mining is concentrated. LFP batteries have several advantages, including a longer cycle life of approximately 2,500 to 3,000 charge cycles, wider temperature range tolerance, and a low self-discharge rate. These batteries also offer superior safety and environmental benefits compared to other cathode chemistries that include cobalt. The absence of cobalt makes LFP batteries less harmful to the environment. Regarding the Rivian-Amazon agreement for the EDV vans, there have been reports suggesting that Amazon has reduced its orders from Rivian. If Rivian successfully terminates its exclusive agreement with Amazon, it could potentially sell the EDV vans to other companies. However, the specifics of this situation and its impact on Rivian's business are not entirely clear. Rivian's decision to introduce a new motor technology for its vehicles, including both consumer and commercial platforms, could help the company achieve cost efficiencies and expand its market. The new motor technology will be implemented in the RCV platform supporting the EDV vans first, followed by the R1 vehicles. This move aligns with Rivian's goal of offering accessible price points and broadening its addressable market. While LFP batteries may have a lower energy density compared to other battery chemistries like NMC, nickel manganese cobalt, they are generally less expensive to manufacture. The CEO of Rivian is optimistic about the new battery packs and expects improved deliveries throughout the year. Rivian's adoption of LFP batteries reflects its commitment to sustainability and responsible production, offering a glimpse of what the future of electric vehicles could look like. The transition to LFP batteries may take time, but it contributes to creating a more eco-friendly option in the automotive industry.